Hello, everybody. Welcome to our third webinar in the Pro Model series. Mark, if you could just verify you can see my slides.
Yep, I can see it fine.
All right, thank you. Good. All right, so today we'll be discussing how Autodesk and Pro Model can help you find ways to increase throughput through your manufacturing processes and workflows. I'm your host, Jason Flores, an industry consultant here at Applied Software, a GRAITEC company. One of my focuses here is helping customers understand what a digital factory means and how to leverage technology not only to gather data about the factory, but what we can do with that data to help operation folks make decisions that will affect throughput and efficiencies. Co-hosting today and the brains of our operation is Mark Siebert, Senior Consultant. So as I mentioned, this is our third webinar of the Pro Model series. And one of the challenges I've helped customers overcome is the complexity of the digital factory. There's so many pieces of technology that can be used in creating a truly working digital factory. It can be somewhat overwhelming. Things like AutoCAD or factory design utilities, Pro Model, raster design, point clouds, Navisworks, 3D scanning, and that's just to name a few, can really make your head spin. Throughout the series of webinars, we're examining bite-sized pieces of information. We're trying to help demystify the world's digital factory as we know it today. It's easier to achieve than you think, and as you can probably guess, it's more valuable than ever. So have you ever wondered what impacts your shop floor would have if you tweaked things just a little bit? Little things like moving a machine here or there to make more room, adjusting constraints of a machine, or adding more people to a process? It can be tough to understand and predict what would happen. Well, now you can digitally make those changes and analyze the data to optimize your workflow. So today's webinar addresses this challenge and takes you on a journey of just that and shows us how to leverage that analytical data using technology like AutoCAD, factory design utilities, and Pro Model. So with that, I will turn it over to you, Mark, who will run through a demonstration of Pro Model. And as always, feel free to chat any questions you have along the way, and at the end, we can try to address any of those questions you may have. Take it away, Mark.
Thanks, Jason, and good day. On this demonstration, what we're going to do is we're going to take our Pro Model webinars that we've done in the past two sessions. The first session, working with one machine and adding a second machine. The second session, we added a second machine with a second person. And on this session, what we're doing is we're actually going to change the configuration of our workflow to try to handle some of the backups that were happening with our machines. So one of the things that we can do with Pro Model is we can give any entity a value for how much can be handled in that machine. We can put in our hourly cost for that machine. And we can even put a counter on there so we can see how many items are in the machine at one time. Now, we can take this a little bit further, where we can add any setup to the machine as we add the parts in, or we can even set up some downtimes. Now, in this model, we've actually added on another conveyor. And I'm going to click here on my conveyor for my simulation browser. And right here, you're actually seeing that you have two different conveyors that we're running with. The first conveyor is right here, and the second conveyor is here. Now, as we develop where we want to place our machinery, we also have the ability to generate flows. So in this case, we're running a flow that is saying that once it comes from the box container here, it will run along our conveyor belt. It'll be placed in either of the two CNC machines, and on exit of the two CNC machines, it will go to conveyor 2. Once it comes down conveyor 2, it then will hit the degreaser, go to an inspection, and then we're going to put it in finished parts or rejected parts. Now, this simulation is very straightforward, but there's other things that we can do with it. we have what's called a scenario manager. And what the scenario manager will do is it allows you to run multiple scenarios by changing some of the variables that we have in here. So what we can do is we can actually apply times to the different machinery to have some different probability distributions. Now, we're talking probability distributions, and for people who understand the statistics of it, you might know where we're going with it. But to open up our Bluebeam here, what we're talking about probability distributions, we're talking about how we can have different variables for our times. We can do exponential, which is line down on the left-hand side where it's locked in, and it will be the mean of the average time. And then the E is going to be 10 minutes. So over that time, exponential, you're going to see a decrease as you use it longer. Now, if we look at the uniform method, the syntax U with the parentheses, the mean or average divided by the half range. So here we're saying that we're going to use a uniform time of 9 and we're going to have a half range of 1 minute to give us our uniform probability distribution. Now, in most cases, we will use a triangular distribution where we have the minimum, the mode, and the maximum. The mode is the point with highest probability, but it doesn't always necessarily mean it's the mean of the distribution, okay? So you can bound on both sides to give us our triangle. In the example, we have a minimum of 1, a mode of 8.6, and a maximum of 11. So what this is going to do for us is it's going to give us distribution within that triangle. Now, there are many other types of distribution available. We have the Poisson, we have binomial, exponential, which we already covered, a normal, which is an unbound bell curve, the triangular, the uniform that we covered, and the log normal. So all of these probability distributions allow us to give different time captures for our machinery according to the math that makes most sense. Now, getting back into our model, we want to go in here and we want to set up those scenario managers. Right now, notice that CNC2 is using a triangle distribution, while CNC1 is using a normal distribution. Now, different scenarios we want to run. Well, the first one, we're going to call it as increase throughput. And we're going to say okay. And on this one, what we're going to do is this is the mean, or the minimum is 3, the mean is 5, and the maximum is 10. Well, what we're going to do here is we're going to change this to do a mean of 8. So in other words, minimum is 3, the maximum is 10, but the highest percentage is going to fall in the 8 market. Now on CNC2, I'm going to look at changing this to a uniform method. And on the uniform method, what I'm going to do is I'm going to put a U. I'm going to say our mean time is 8, comma 1. And close that parentheses. Now in our decreaser, that is the capacity of the machine. So actually I grabbed the wrong one there. We should have grabbed a different parameter than this one. So what I'm going to do is I'm going to delete this parameter. I'm going to add another parameter so we can get some time in here. And I'm going to location, and we'll look at the hourly cost. No, don't like that one. Hourly cost per use, units, that's capacity. That's our variables. Let's see here. Don't want capacity. Process time. Grease time. There we go. Now, the grease time we're going to change here from a normal. We're going to take that to 3.5 and 1. And then I'm going to add one more scenario. And this scenario is changing the grease time to a triangular. So I'm going to come in here. I'm going to go a T distribution with a minimum of 2, a mode of 4, and a max of 6. And I'm going to keep this at normal, and I'm going to keep this at normal. So we've got one that is going to change the speed of our CNC machines as well as the degreaser. And then we're going to run another scenario that is going to compare the CNC machines to be at the same time, but now we're going to run a triangular probability on the degrease time. Now, we can come in here and run all scenarios. And as it goes through all the scenarios, and let's just speed this up a little bit. And as you can see, our people are in their right cells. So C1 is working on the CNC, C2 worker is working on just the degreaser and the inspection, and then applying it to your view. Now, since it's run the scenario manager, now I have the ability to see different numbers. So I have the baseline. My throughput is at 4.16. If I go to my increased throughput, notice that my time went up to 5.39. And the final one, the grease time. That throughput went to 4.15. So I can add all these scenarios to be in my same report, and now I can start seeing how different data is applying to our different tools. In this case, we've run it faster on our CNC machine. So if you notice on the increased throughput for the CNC machine, this CNC 1 is in a wait mode more than it is blocked, where CNC 2 also is not being blocked as much because the time method is actually setting there to wait. So Pro Model doesn't just look at the workflow of the items coming through, it actually gives you the what if scenarios to take out that block time if you need to, or to find different states of when we need to be running through the product and when it's not. Now, again, there's a lot of different features out of the Pro model. And by just controlling how our operators are running in just between the CNC machines, and operator 2 is just running in this little loop here. You can do what if scenarios as well on your operators. There's your C1 operator. You can say how many units he can handle, what his hourly cost is, but you can also direct where the path is that he's going to be following, how fast he's going on it, as well as if there are downtimes for breaks, lunches, things like that. So, Pro Model can handle calendar days, it can handle scheduled downtimes, and it can do math for you on your flows to make sure that your products are coming through at a fast pace. Now, again, once we get into our output viewer, all the numbers are going to start running for us. And since we ran those multiple scenarios, now you're seeing every scenario within the same report. And now we can just say, we want to see a resource for our baseline. Well, add on your 3 scenarios, and now you can see where the increased throughput actually increased your work. I hope this explains to you how ProModel isn't just a model to help with the workflows, but it's also a model to help with deciding on machine flow. If the machine is too old, if the machine's new, you have the ability to change the throughput on those machines. Misty, have any questions or comments that we need to take care of?